Okay, what's the sign of 30?
1/2. 0.5.
What is the sign of 45?
Radical 2.
Radical 2 over 2. What's the sign of 60? Radical 3 over 2. Look at this pattern. The first one is the same thing as radical 1 over 2. As radical 1 is 1. Radical 1 over 2, radical 2 over 2, radical 3 over 2.
1, 2, 3. 1 over 2. Wow, why didn't you tell us that earlier?
I told some people.
You didn't tell me.
I'm in my other class. Alright, cosine of 30 is the same as the sine of 60. So this is radical 3 over 2. Cosine of 45
It's radical 2
is
over
the
2.
same as the sine of radical 40, or sine of 45, so radical 2 over 2. And then this one's radical 3 over 2, this one's radical 2 over 2, this one is radical 1 over 2, or 1/2. So the signs, as you go up in angles, the signs increase. The cosines decrease. Tangent. Tangent of 30 is the one with all the 3's. So tangent of 30 is the one that we had, square root of 3 over 3. Tangent of 30 is the one with all the 3's. Tangent of 30 is square root of 3 over 3. You got to remember it. Tangent of 45, since it's an isosceles triangle, both sides are the same, tangent is 1. And then tangent at 60 is the reciprocal of tangent of 30. That one's square root of 3. Those you're going to have to memorize. I remember one of them square root of 3 over 3. I remember the other one square root of 3. But to remember which one's which, the one with all the 3's goes with the 30. Now for this side, what do? You just reciprocate all of this. So we'll have 2, we'll have radical 2, and then we'll have 2 radical 3 over 3. And keep reciprocating. 2 radical 3 over 3, radical 2, and 2. And then the cotangent, we just reciprocate all the tangents. So radical 3, 1, and then radical 3 over 3.
I did it.
Do it by yourself. You're going to have to. So before break, I gave this to you on that quiz. Remember? I gave that to you on the quiz. And now I will not be giving that to you anymore, so you have to start memorizing.
Would we have to chart, like, so we could like, fill that in?
No, but you can always make your own if you'd like.
That's not a way.
So if you memorize it, you don't have to fill out the chart.
Or I could just remember the triangles.
Yeah, you can do it that way too. It takes longer. All right, so today I'm going to draw like over to the side before we kind of read this. Today we're going to be finding sine, cosine, and tangent of a terminal side within a circle.
That means end.
Yes,
side.
it does. So I'm just going to sketch a circle over here. Sketch a circle. And I'm going to draw the first side. What's the first side called?
A radius.
The initial side, right?
How many radius?
It is
are
the
in that
radius.
circle?
And then I'm going to draw a terminal side. I'm going to draw a terminal side right here. And that terminal side ends at an ordered pair somewhere on your X and Y chart, on your graph. It doesn't matter what the angle is at this moment. What matters at this moment is that this is an ordered pair that is X comma Y. How do we get to that ordered pair from the origin? What do you do when you graph that ordered pair from the origin? How do you get there?
Just draw the line.
What? No. When I give you an ordered pair and I say graph it, what do you do?
Count.
How?
Solve for it. I gotta do the function.
Oh man, you guys are like making this way more complicated.
Yeah,
If I give you the ordered pair negative, they didn't give me one. If I give you the ordered pair negative 3, 4.
So you go left 3, up 4.
So you use which variable first?
X.
X, and then we use
Y.
Y, right? No, it is not.
I mean, you could go up and then left.
But you don't, because it's an ordered pair and you go in order. And if you don't go in order, you're gonna make a lot of mistakes on this section. So from the origin, we go
Just like,
X, and then we go Y. And when you go X, then Y, you make a right triangle with the radius.
Whoa.
When you go X and Y, and we end up at that ordered pair, this is a right triangle where the radius is the hypotenuse. It's a right triangle. Because it is a right triangle, we can find the sine, the cosine, and the tangent, and the other reciprocal functions. All by knowing just what the ordered pair is. If we only know two sides, how do we find the third one? If we know, yeah, it's the Pythagorean theorem. If we know two sides of a right triangle, we find the third one by doing Pythagorean theorem. But in this case, it would be like x squared plus y squared equals r squared. Same thing as a squared plus b squared equals c squared. Same thing. Just different variables. Right. So if I asked you to find the sine of theta, my theta is out here. But when we go to find the sine, you use the angle that is next to the origin. Use the angle that is next to the origin. When we go to find the sine of this picture, you're going to do what over what? Sine is what over what? SOHCAHTOA. Sine is opposite over the hypotenuse. We're going to have y over r. If you go to find the cosine, you're going to have x over r. If you go to find the tangent, you're going to have y over x. And all of that is written for you on this paper. All of the formulas are written here. This would be something we have to start memorizing. That sine is y over r. That sine is y over r. And I'm saying it weird because that's how I remember that sine goes with y. I don't know how else you remember it, but cosine is x over r. Sure. Okay. And then tangent is y over x. And if you write them in order, we've got y over r, x over r, and then y over x. So like it goes kind of in order. Y over r, x over r, y over x. And then for the cosecant, the secant, and cotangent, you just flip each of those first. You only have to memorize 3 of them. So here, we have the ordered pair, -4, 3. That is the ordered pair. We're going to find the sine, cosine. We're going to find all 6 trigonometric functions of this theta.
Y over R.
So if you need to label the sides of your triangle to help you, you can. What would be this side of my triangle? How far do I go?
-4.
I go -4, and yes, you need to include the negative. And then I go up how far? 3. But what is my radius?
No.
We'll find out next time on this.
No, we'll find it right now. Who knows that?
After
Right.
the break.
Why is it 5?
The triples.
3, 4, 5. There is a negative though. So the negative tells us which direction we're going, either left or right, up or down. Negatives tell us direction, but the radius itself is a length. The radius cannot be negative. Or if you do the Pythagorean theorem and you do -4 squared plus 3 squared, you get positive. So it's always going to be a positive answer for the radius, always. Always.
You promise? You pinky promise?
I do. Okay, so sine is y over r. So we find our y. What is our y?
3 over 5.
And our r is 5. And then cosecant, just flip them. Our cosine is x over r. So we do -4 over 5. But when you flip them, the negative does not go in the denominator. So we write -5/4. So don't leave the negative in the denominator. That would not be simplified. And then tangent is y over x. And I'm asking you to say those with me, the y over x, so that you remember them quicker.
Tangent, y over
I
x.
already got
Sine,
Excellent. Good for you.
sine.
So I'm going to do 3 over -4, which is -3/4. And then I flip it to -4/3.
You try this.
We're going to do another one together. You will get to try one on your own, and if you work ahead, that's fine too. All right, the next one. We need to figure out where our triangle is and figure out our radius. So this ordered pair is 3, -3. That means I start at the origin and I go +3 on the x, and then -3 on the y.
Oh, that's a 45, 45.
And if you do realize that, you just save yourself a lot of time. Gosh, I can't draw that. So we've got 3, -3, and then we have to find the hypotenuse.
You simplify it.
What? You almost simplified the answers already, yeah. So to find the hypotenuse, do we use Pythagorean theorem? Or is this a triple? Not really a triple. Because a triple that wouldn't have a square root in it. It's called a special right triangle. It's what?
Is it 3 radical?
It is 3 radical 2.
Huh.
But if you remember that, if that comes in handy, like with stuff you learned in geometry last year, if you remember 3 radical 2, you just saved yourself a lot of time. If you forgot, and we do the Pythagorean theorem, we're still going to get it. You do 3 squared plus -3 squared equals r squared. You'd have 9 plus 9. So 18 is r squared, then you square root it, and you get 3 radical 2. So knowing your special right triangles would save you some time. And then the sign, we're going to do the y over the hypotenuse. Okay, hold on a second. I wanted to write y over r and I forgot. Okay. So what you can do is you can cancel out the 3's. But you still have that radical 2 in the denominator, so you have to rationalize it by multiplying by square root of 2 over square root of 2. And we get negative sign radical 2 over 2. And if you look back at your chart and you looked at the sine of a 45-degree angle, because this one is isosceles, it is 45 degrees. If you look at the sine of 45, it is radical 2 over 2. The negative tells us that it's in a different quadrant than the normal quadrant, number 1. The negative's just putting it somewhere else. Okay, for cosecant, what's the cosecant of 45 degrees? It's radical 2, but if I'm flipping this one, it's actually negative. So we're going to do this stuff again. With cosine, we've got x over r. So I'm going to put my x, which is 3, over 3 radical 2. And I can cancel, and I can rationalize. But it's going to equal radical 2 over 2. And then my secant, I'm going to flip that one. It's going to be positive radical 2. My tangent, what is the tangent of 45 from your chart?
1.
It's 1, but is this one 1? We're going to put x, no, we're not going to put x. Don't listen to me yet. We're going to put y over x, so I'm going to put negative 3 over 3, and that is negative 1. And we flip it, and we get negative 1. So these negative signs would be coming up because of which quadrant they're in. It's still 45 degrees. It still has all the same answers for 45 degrees on that warm-up chart. Okay, next one. We've got x is negative 8, y is 15.
Remember, this is triple.
So what is r?
17.
So that is a triple. We spent a day on triples hoping that you'd remember some of them and save you some time. Otherwise, Pythagorean theorem. So sine is the y over the x. Negative. No, it's not over the x. That's tangent.
That's,
I
that was
don't know what I'm saying. Y over r. I need to write them down.
15.
Okay. So what is it? 15 over 17. 17 over 15. This one is negative 8 over 17, so negative 17 over 8. And then this one would be 15 over negative 15 eighths, and that would be negative 8 fifteenths. All right, last one you try. You try that one.
Oh, one step ahead of
Good. Coming. Just a second. If you know your triples, some of these are going to save you some time. You know your triples, some of these will save you some time. If you don't know your triples, how are you finding?
Pythagorean
You're
theorem.
going to do Pythagorean theorem if you don't know your triples.
it.
In your homework, those of you that are done, you can just listen for a moment. In your homework, some of them aren't triples, and you do have to use Pythagorean theorem. You have to go on the whole page. Pythagorean theorem, or just really fast. That's what it's like. Good. That's okay. Wait, am I coming? That's why. Yep. All right. Putting answers up. Either by Pythagorean theorem or by knowing your triple, your radius is positive 13, positive 13, positive. Okay. And then we go through and we find our sign and flip it, and our cosine and flip it, tangent. Our tangent has two negatives, so yes, those two negatives cancel each other out and become positive for tangent. Just remember that sine is y over r, cosine is x over r, and tangent is y over x. Good? We're going to do example 2, and then that's all we're covering today. So we've got a few different questions to try, but example 2 is as far as we're getting today. The unit circle has the word unit in it. That means that the radius is 1. If the radius is 1, it is called the unit circle. If the radius is 1, it's called unit circle. And then if the radius is 1 and we go to find the sine of theta, or the cosine of theta, and we put it over 1, we do y over r, we put it over 1, then the sine is equal to y, and the cosine is equal to just x. So if we know it's the unit circle, all you have to do is look at the y value and that's the sign. You don't even need the over r because it's 1. If we know it's a unit circle. The tangent of the unit circle. What's the tangent formula?
Like, so y over x.
Y over x. So since that does not have an r in it, it doesn't change. It's still y over x. It is very convenient to use the unit circle when we are trying to find values, sine, cosine, and tangent of things that are called quadrantal angles. So we have our unit circle. Here it is. Let's try that again. One more time. Oh well. We've got our unit circle, and each point where we are not inside the quadrant, but like on the actual x or y axis, those are called quadrantal angles. So this one would be at either 0 or 360 degrees. This one would be what? 90 degrees? 180 degrees? Yeah, you're right with the negatives. But you're right. And then 270 degrees. And then Alex is saying like negative 270 when I wrote 90 because those are the same. Yeah. But you can, if you need the negatives, you can put those in. And then what we really need is we need the ordered pair, because that's what we were just using, the x's and the y's. So we need the ordered pair of this point. So what ordered pair is this point? How far are we going over? 1, because it's the unit circle, so the radius is 1. And then we go up or down 0. So for 90 degrees, the ordered pair is what? 0, 1. And then for 180 degrees, we're going to the left. Negative 1, 0. And then 270 degrees is down, so it's 0, negative 1. Those are the quadrantal angles. That's what we call the quadrantal. Okay, so you may have written that on your paper up where I have it. Maybe you wrote it down next to the next question. I'm going to rewrite it because I need it next to the next question, but mine's on a different page. So I'm just going to copy it again right over here, kind of. Well, I'm not copying the whole thing. This says, use the unit circle to evaluate 6 trigonometric functions of when theta is 270. So where's 270? What ordered pair? At 0, negative 1. Sine is y, but over 1. Cosine is x, 0. And then tangent is y over x. So when I do y over x, I'm just using, if you look right here, I just wrote y and then I just wrote x. I'm just putting that number over that number. Negative 1 over 0 is
Error.
undefined. No. You write undefined.
Can we abbreviate that?
No.
Why not?
Because you asked.
There's no R in
Okay,
for
because you
undefined.
just flip negative 1, and when you flip negative 1, we still get negative 1. Secant. What happens if you flip 0? 0 is currently over what number?
1.
So when I flip that and I get 1 over 0, what do I have here?
Undefined.
I have undefined. Remember, you're not allowed to divide a number by 0. A number divided by 0 is no. So do it.
I get it.
And then for cotangent, we do x over y. We flip tangent, we do x over y. So if I flip negative 1 over 0, I now get 0 over negative 1. You can kind of use this one to see what it's going to be. What's 0 over negative 1? 0. If you take 0 and you divide it by negative 1 in your calculator, it will tell you 0. But you can't divide by 0. Okay, let's try another one of those.
Let's go back to like second grade. You take nothing and you're supposed to split it between your negative 1 friends, and you have nothing.
You don't have negative 1 friends, do you?
No, but it didn't say -1. You know how like.
Okay, so 90 degrees is the next one, and what ordered pair is 90 degrees?
You have 6 apples and you're sharing them between 3
1,
friends.
0.
How many apples does every friend get?
It's going up.
Not 1, 0.
0, 1, no. They said 1,
You
0, 1.
really like that, Miss Griswold?
1.
I'm just writing whatever you all say.
No.
Okay, so the sign is Y. The sign is Y. The
Oh,
sign
that's
is
1.
0.
One.
I'm just making my number mixed up.
Uh-huh. And the cosine is X.
0.
So 0. And the tangent is Y over X. So we do 1 over 0.
Undefined.
Undefined.
So what's the abbreviation for undefined?
Undefined.
Undefined.
Okay, then when we flip cosine, when we flip 0, we get undefined. And then when we flip undefined, when you flip 1 over 0, you get 0 over 1. So 0. All right, on the next page is a U try.
I thought you said this was.
We have 3 times, but it's example 2. It's all example 2.
Oh my gosh.
So that is the last example.
Can I Google? This
Well, you
one-
won't be able to do the order pairs yet.
Are we sure?
That's not today.
I was-
But that's not what we're doing. We're doing things with that. You.
Okay, you want to get it right?
It is.
Thank you.
So you have to know what the sine of 45 and the cosine of 45, because that's the x and that's the y. And that's what we're doing. Okay, so you're doing the one at the top. I'm coming around and checking it. If you get it done, you can start looking at that lovely chart underneath. Good, so you figured something out. There are some things you can't answer. There's a lot of things you can't probably answer yet. Something. That. Let zero. Right. So you started figuring some of them out. I know you can figure out what you do. We'll probably won't be able to get any other order here. Okay, so. Pretty cool. You could probably get some of the order pairs here. The rest of them probably not. Yeah. But you could definitely do the degree. So figure out the degrees. But that's for tomorrow anyway. Your top. Okay, are you putting degree measures in? Some of the order pairs?
Got it. So
can you figure out this, like, 4 order pairs?
Because that is X. Yes, sir.
So we're using 180 degrees for this one. Some of you have already checked off, and you're working on the other part at the bottom. So your assignment today is just going to be over the first 2 examples that we went over. The assignment is in the book. You can either pull up a book online, or you can borrow one of my books. I have 5 of them, or you can take a picture of one of my books. But if you use one of my books, I ask you to put them back. Otherwise, bring your own book. And then just a heads up, because of the schedule being all crazy and there's a lot of testing going on, like I don't have the laptop cart checked out all those days because they need it for the testing. So we're probably going to be doing a lot of homeworks that are not online. So bring paper, maybe bring a book. This is going to be, a lot of this will be out of the book or worksheets for the next couple weeks, yeah. I don't know, let me look for you.